Dear students, this is B. Ramarao from SRRS Government Polytechnic College, Sircilla. General Engineering Chemistry for first year diploma first sem students. Acids and bases chapter we discuss topic buffer solutions. Buffer solutions. What is buffer solution? How many types of buffer solution? What are the importance of buffer solutions? This hour we discuss about buffer solutions. Discuss about buffer solution in this hour. Buffer solutions. Objectives. In this hour we discuss about buffer solution, types of buffer solutions, importance of buffer solutions. On the completion of this period, you would be able to know. On the completion of this period, you would be able to know introduction, definition of buffer, types of buffers, introduction, definition of buffer solution, types of buffer solutions, action of buffer solutions, action of buffer solutions. Introduction, definition of buffer solution, types of buffers, action of buffer solutions. Action of buffer solution. Introduction. What is an acid? What is a base? According to Arrhenius, acid substance dissociated in aqueous solution, it produces H+ ions is called acid, like HCl, H2SO. According to Bronsted-Lowry theory, substance donate proton to another substance is called Bronsted-Lowry acid, like HCl, H2SO. Lewis acid. A substance accepts pair of electrons from another substance to form a coordinate covalent bond is called Lewis acid. What is a base? According to Arrhenius theory, substance dissociated in aqueous solution, it produces hydroxyl ions is called Arrhenius base. A substance accepts a proton from another substance is called Bronsted-Lowry base. Like example, NH3, H2O, OH-. According to Lewis base, a substance, a pair of electrons donate to another compound to form coordinate covalent bond is called Lewis base. Arrhenius acid, Bronsted-Lowry acid, Lewis acid. Arrhenius base, Bronsted-Lowry base, Lewis base. What is a buffer? Now we discuss what is a buffer. Sodium chloride. Sodium chloride. Solution is neutral. Sodium chloride solution is neutral. That is pH is 7. If 1 ml of 0.1 m HCl added to 1 liter of NaCl solution, pH 7 of sodium chloride solution present. 1 ml of 0.1 m HCl is added to 1 liter of NaCl. Then pH decreased to 4. Then pH decreased to 4. If 1 ml of 0.1 m sodium hydroxide is added to 1 liter of NaCl solution, the pH increased to 10. HCl added 1 ml in NaCl solution, then decreased 7 to 4. In case 1 ml of sodium hydroxide added to pH 7 in NaCl solution, then increase 7 to 10. That is, pH of a solution decreases by adding strong acid and increases by adding strong base. It is found that many biochemical reactions takes place at definite pH value. The pH of blood should be maintained of 7.35 for its proper functioning. The pH of blood should be maintained of 7.35 for its proper functioning. In some industrial or laboratories reactions, the pH needs to be maintained constant. Buffer solutions are in this type of reaction. A solution which resists change in its pH value. Change in its pH value by adding small amount of strong acid or strong base or on dilution is called buffer solution. A solution which resists change in its pH value by adding small amount of strong acid or strong base or on dilution is called buffer solution. What is a buffer solution? Mixture of two substances. Buffer solution maintain constant pH by adding small amount of strong acid or strong base or dilution. It maintains constant pH value. Such solution is called buffer solution. These buffer solution prepared by mixture of two substances. It is prepared by mixture of two substances. Mixture of two substances. It maintains constant pH value. Resist the change in pH. It maintains constant pH. It is prepared by two substances. It resists the change in pH value. Addition of strong acid or strong base does not change the pH. What is a buffer? It maintains constant pH. It resists the change in pH by adding strong acid, a strong base, or an dilution is called buffer solution. Addition of strong acid or strong base does not change the pH. This solution is called buffer solution. It is mixture of two substances. It maintains constant pH. By adding small amount of strong acid or strong base on dilution is called buffer solution. Example of buffer solution. These buffer solutions are two types. One is acidic buffer solution. Second one is basic buffer solution. Acidic buffer solution, basic buffer solution. Buffer solutions are two types. One is acidic buffer solution, another one is basic buffer solution. Acidic buffer, basic buffer solution. Acetate buffer, carbonate buffer, phosphate buffer, ammonia buffer. Buffers are mixture of two substances. One is acetate buffer, acetic acid plus sodium acetate, sodium acetate. Carbonate buffer, carbonic acid, sodium bicarbonate, sodium bicarbonate. Phosphate buffer, phosphoric acid, phosphorus acid, sodium biphosphate. Ammonia buffer, ammonium hydroxide and ammonium chloride. Types of buffers. Buffer solutions are two types. One is acidic buffer, second one is basic buffer. Acidic buffer, basic buffer. Buffer solutions are two types: acid buffer solution, base buffer solution. Acid buffer solution, base buffer solution. Acid buffer solution. An acid buffer is prepared by using weak acid and its salts of strong base. This is called acid buffer solution. Acidic buffer solution prepared by mixture of weak acid and its salt with strong base. This is called acid buffer solution. It is a mixture of weak acid and its salt of strong base. Weak acid and its salt of strong base mixture is called acid buffer solution. Acidic buffer solution. Acidic buffer solution pH is less than 7. pH less than 7. pH less than 7 by prepared weak acid and its salt with strong base mixture is at acidic buffer solution. Like example, acetic acid and sodium acetate. Mixture act as acid buffer solution. CH3COOH plus CH3COONA. Acidic buffer. Acetic acid and sodium acetate. H3BO3 Na2 B4 7. Boric acid borax. Boric acid borax. H3BO3 plus Na2B4O7. Na2B4O7. H3BO3 plus Na2B4O7. Boric acid plus borax act as acid buffer solution. Some acidic buffer solutions, carbonic acid and sodium bicarbonate. Carbonic acid H2CO3, sodium bicarbonate NaHCO3. Carbonic acid H2CO3, sodium bicarbonate NaHCO3. Phosphoric acid sodium dihydrogen phosphate. Phosphoric acid H2H3PO4 sodium dihydrogen phosphate NaH2PO4 sodium dihydrogen phosphate. These mixture all act as acid buffer solutions. Acetic acid, sodium acetate, carbonic acid, sodium bicarbonate, boric acid, borax, phosphoric acid, sodium dihydrogen phosphate. Sodium dihydrogen phosphate. These all are act as acid buffer solutions. Base buffer solutions. Base buffer solutions. A buffer is prepared by mixture of weak base and its salt with strong acid act as base buffer solution. Base buffer solution. It is a mixture of weak base and its salt of strong acid. Salt of strong acid act as base buffer solution. Basic buffer solution. pH is more than 7. pH is more than 7. The best example of basic buffer is a mixture of ammonium hydroxide and ammonium chloride. The buffering action of basic buffer can be explained as follows. Weak base NaOH react with strong acid HCl. React with HCl, then form NH4Cl plus H2. These weak base react with strong acid, then form salt ammonium chloride. The weak base and its salt with strong acid to form base buffer solution. This base buffer solution pH more than 7. For example, ammonium hydroxide plus ammonium chloride. Ammonium hydroxide, ammonium chloride act as base buffer solution. Base buffer solution. Aniline plus anilinium chloride. Anilinium sodium chloride. Mixture is act as a base butter solution. Base butter solution. Aniline, anilinium chloride. Anilinium chloride. C6H5NH2, C6H5NH3Cl, C6H5NH2, C6H5NH3Cl. These mixture act as base buffer solution. Buffer action. Resisting any change in pH of buffer is called buffer action. Buffer action means resisting any change in pH of buffer is called buffer action. Action of acid buffer. Acidic buffer, like example acetic acid, sodium acetate. These acetic acid ionization CH3COH to form CH3CO minus plus H plus. Partial dissociation. Acetic acid dissociated partially acetate ion plus H plus ions. Sodium acetate CH3CO minus plus Na plus. Complete dissociation. Partial dissociation, complete dissociation. On addition of strong acid. On addition of strong acid. This buffer is prepared by mixture of acetic acid and sodium acetate solution. In this solution, the weakly ionization of acetic acid will be equilibrium with acetate ion and H3O plus ions. Sodium acetate, being a salt, completely ionization acetate ion and sodium ions. CH3COONA to form CH3CO minus plus Na plus. So, acetate buffer contains acetate ions, H3O plus ions and sodium ions. If a few drops of strong acid added to buffer solution, the added H plus ions combined with acetate ions to form properly ionized acetic acid. Hence pH remains constant. These acetate ions interact with H plus ions to form undissociated acetic acid. So H plus ions does not increase in buffer solution. HCl gives H plus Cl minus. CH3CO minus react together to form undissociated acetic acid. So, a few drops of strong acid added to buffer solution, the added H plus ion combined with acetate ions CH3CO minus to form properly ionized acetic acid. Hence pH remains constant. Action of acetic buffer and action of strong base. Similarly, if a few drops of strong base are added to the buffer solution, hydroxyl ions added to base react with acetic acid to form water and state ions, hence pH remains constant. Base NaOH to form Na plus OH minus. These acetic acid interact with OH minus ions to form state ions plus H2. Hence pH remains constant. Buffer solution CH3COOH partially dissociation to form state ion plus H plus ions. CH3CONA completely dissociation to form Na plus CH3CO minus. On addition of strong acid, these H plus ions react with acetate ions to form undissociated acetic acid, then pH remain constant. On addition of strong base, these OH minus ions react with H plus ions to form undissociated water molecule, then OH minus does not increase in mixture of vapor solution, hence pH constant. Basic buffer solution. Now we discuss basic buffer solution. Mechanism of buffer action upon acid buffers. Action of base buffer. Base buffer. Basic buffer solution mixture of weak base and its salt with strong acid act as base buffer solution. Ammonium hydroxide and ammonium chloride. Ammonium hydroxide partially dissociated to form NH4 plus OH minus. NH4 plus OH minus. Ammonium chloride completely dissociated to form NH4 plus Cl minus. Ammonium hydroxide and ammonium chloride. Thus, ionization reaction is represented by this following equation. On addition of strong acid. On addition of strong acid. When a few drops of acids are added, the H plus ions of the acid combine with ammonium hydroxide and form NH4 plus undissociated water molecule, hence pH constant. HCl to form H plus Cl minus. These H plus ions react with ammonium hydroxide to form undissociated water molecule, hence pH is constant. Action of base buffer solution. As added H plus ions are reacted, pH remains constant. Similarly, if a few drops of base added to basic buffer solution, the hydroxyl ions of base combine with NH4 plus ions to form undissociated ammonium hydroxide, hence pH constant. NH4 plus OH minus to form ammonium hydroxide. On addition of strong acid, on addition of strong acid. pH constant. On addition of strong base, OH minus ions interact with ammonium ions to form NH4OH, hence pH constant. NH4 plus OH minus ions to form NH4OH, As added OH minus ions are reacted, pH remains constant. Base buffer solution. Ammonium hydroxide and ammonium chloride mixture is called basic buffer solution. Ammonium hydroxide weak base, it is partially dissociated to form NH4 plus OH minus ions. Ammonium chloride completely dissociated to form NH4 plus Cl minus ions. On addition of strong acid, these strong acid H plus ions interact with OH minus ions to form undissociated other molecule, hence pH constant. On addition of base, these base hydroxyl ions interact with ammonium ions to form undissociated ammonium hydroxide, hence pH constant. Hence pH constant. This basic buffer solution pH does not change by adding strong acid or strong base or dilution. pH remains constant. Mechanism of buffer actions of basic buffers. Summary. Buffer solution maintains constant pH by adding small amount of strong acid and strong base. Buffer solution maintain constant pH by adding small amount of strong acid and strong base. Buffer, it maintains constant pH. It maintains small amount of strong acid or strong base, but it will maintain constant pH. A solution which resists change in its pH value by adding little amount of strong acid or strong base or on dilution is called buffer solution. Buffer solution. Buffer solution maintain constant pH by adding small amount of strong acid or strong base. Strong acid or strong base. Buffers are two types, acidic buffer and basic buffer. Buffers are two types. It maintains constant pH by adding small amount of strong acid or strong base. Buffer solutions are prepared by mixture of weak acid and a salt of strong base is called acidic buffer. Buffer solution is a mixture of weak acid and its salt of strong base is called acidic buffer. Like acetic acid, sodium acetate, CH3COH, CH3COONA, carbonic acid, H2CO3, sodium bicarbonate, NaHCO, phosphoric acid, sodium dihydrogen phosphate, H3PO4, NaH2PO4. Basic buffer solution. A buffer solution prepared by mixture of weak base and its salt of strong acid is called basic buffer solution. The best example of basic buffer is a mixture of ammonium hydroxide and ammonium chloride. The buffer action of basic buffer can be explained as follows. Like ammonium hydroxide, NH4OH and ammonium chloride, NH4Cl, ammonium chloride, ammonium hydroxide, ammonium chloride, and ammonium hydroxide and ammonium nitrate, NH4OH plus NH4NO3. Acidic buffer, basic buffer. These are two types of buffer solutions. Prevention of change in pH is called buffer action. Buffer action means prevention of change in pH is called buffer action. Buffer action. What is action? Prevention of change in pH is called buffer action. These buffer actions, acidic buffer action and basic buffer action. These acidic buffer action, by adding strong acid, these H plus ions interact with acetate ions to form undissociated acetic acid, hence pH constant. In case base added these acidic buffer solution, OH minus ions interact with H plus of acetate ions to form undissociated water molecule. Hence, pH constant. That's why basic buffer solution, by adding H plus ions, these H plus ions interact with ammonium hydroxide to form undissociated water molecule, hence pH constant. These basic buffer solution, by adding a base, interact with ammonium ions to form undissociated ammonium hydroxide, hence pH constant. Please. First one, pH of acidic buffer, pH of acidic buffer. Seven, A, B, 9, C, less than 7, D, 11. Answer, less than 7. pH 7. pH 9. pH less than 7. pH 11. Acidic buffer, like mixture of weak acid and its salt of strong base. So, weak acid like acetic acid, carbonic acid, boric acid, any one, it maintains less than 7 pH. So, answer less than 7. C is answer. Another one, second one, base buffer is a mixture of, base buffer is a mixture of strong acid and strong base, weak base and its salt of strong acid, C, weak base and its salt of weak acid, D, weak acid and its salt of weak base. Base buffer solution is a mixture of weak base and its salt of strong acid. So answer B. Weak base and its salt of strong acid. is called base buffer. So answer B. Weak base and its salt of strong acid. Example of acid buffer. Example of acidic buffer. HCl plus NaOH, HCl plus NaOH, NH4OH plus CH3COH, CH3COH plus CH3COONE, NH4OH and NH4C. Acidic buffer is a mixture of weak base and its salt of strong base. HCl NaOH. HCl strong acid, NaOH strong base. Strong acid, so it is strong. NH4OH weak base, CH3COH weak acid. Weak base, weak acid. It is also wrong. CH3COH weak base plus CH3COONA and its salt with strong base. So answer is C. NH4OH plus NH4Cl. Weak base and its salt with strong acid base buffer. So acidic buffer solution like example CH3COH, CH3COONA. Answer C. C CH3COH plus CH3CO. CH3COH weak base, it is partially dissociated to form CH3CO minus plus H base. CH3CONA, it is completely dissociated to form CH3CO minus plus Na plus. So answer is C. Acidic buffer. C is answer. As per this topic, frequently asked questions: define buffer solution. Define buffer solution. What is buffer solution? A solution which resists change in its pH value by adding small amount of strong acid or strong base or on dilution is called buffer solution. What is a buffer? A solution which resists change in its pH value by adding strong acid or strong base or on dilution is called buffer solution. Explain different types of buffers with example. Buffer solutions are two types: acid buffer solution, base buffer solution. What is acid buffer solution? A buffer solution is a mixture of weak acid and its sort of strong base is called acidic buffer. Like example, acetic acid and sodium ester, CH3COH, CH3COONA. Basic buffer solution. A buffer solution is a mixture of weak base and its salt of strong acid. Is act as basic buffer solution like ammonium hydroxide, ammonium chloride, NH4OH, NH4Cl, NH4OH, NH4Cl. What is buffer action? Buffer action. An addition of strong acid or addition of strong base or on dilution pH maintain constant solution is called buffer action. Explain the action of buffer with an example. Explain the action of buffer with examples. These buffer actions, acetic acid, partially dissociated, sodium acetate, completely dissociated by adding acid, it reacts with acetate ions to form undissociated acetic acid. By adding base, acetate ions react with base to form undissociated water molecule, hence pH constant. Basic buffer solution, ammonium hydroxide, weak base, partially dissociated, ammonium chloride, strong base, strong salt to form completely dissociated by adding acid, ammonium hydroxide, interact with H+ ions to form undissociated water molecule, hence pH constant. By adding base, ammonium ions interact with OH- ions to form undissociated ammonium hydroxide, hence pH constant. This is our topic. Thank you. Thank you once again.